Imagine identical twins. They share the same DNA, the same upbringing, and often, the same experiences. But what if their paths diverged in the most extraordinary way? They are about to embark on extraordinary journeys that will change their lives forever. One twin, let's call her Stella, stays on Earth. She continues her daily routine, living a life filled with familiar faces and places. Her twin brother Scott, on the other hand, boards a spaceship. He is set to explore the vast unknown of outer space. Scott's spaceship is not just any spacecraft. It is designed to travel at incredible speeds, far beyond what we experience on Earth. It travels at speeds approaching the speed of light, pushing the boundaries of human exploration and technology. After what seems like many years to Stella, Scott finally returns to Earth. But for Scott, the journey felt much shorter. He is greeted by Stella. But something is different. The twins, once identical, now appear drastically different in age. Stella has aged significantly more than Scott. How is this possible? How can two people who were once the same age now look so different? The answer lies in one of the most mind-bending theories of all time, Einstein's theory of relativity. This theory, proposed over a century ago, has profound implications for our understanding of time and space. This is the essence of the twin paradox. It's a thought experiment that challenges our perceptions of time and reality. It illustrates the strange but true consequences of Einstein's theory. Time dilation, a key aspect of relativity, means that time can pass at different rates for different observers. This theory has revolutionized our understanding of space, time, and gravity. It shows us that the universe is far more complex and fascinating than we ever imagined. And so, the tale of two twins becomes a story not just about family, but about the very fabric of the cosmos itself. Before Einstein, we thought time was constant. Everyone, everywhere, experienced time at the same rate. But Einstein shattered this notion. He showed that time is relative. It depends on your motion. Einstein's theory of relativity is actually two theories. They are special relativity and general relativity. Special relativity deals with objects moving at constant speeds. General relativity deals with gravity and acceleration. The twin paradox is explained by special relativity. This theory tells us that time slows down for objects moving at high speeds. This phenomenon is called time dilation. Time dilation might sound like science fiction, but it's real. It has been experimentally verified countless times. The faster you travel, the slower time passes for you relative to someone stationary. Think of space-time as a fabric. Massive objects like stars and planets create warps in this fabric. These warps are what we experience as gravity. Now imagine a spaceship traveling through this warped space-time. The faster it goes, the more it cuts through the warps. This cutting through is what causes time to slow down for the spaceship relative to someone back on Earth. One compelling piece of evidence for time dilation comes from atomic clocks. These are the most accurate timekeeping devices ever created. Scientists have flown atomic clocks on airplanes. They have sent them up in rockets. These experiments have shown that the clocks on the planes and rockets tick slightly slower than clocks on Earth. The difference is tiny, but it's measurable, and it perfectly matches the predictions of Einstein's theory. These experiments prove that time dilation is not just a theoretical concept, it's a real phenomenon. It has tangible effects on our measurements of time. Section 5. A trip to the stars and back. Imagine embarking on a journey that takes you beyond the confines of our planet, into the vast expanse of space. A journey where the stars are your companions and the galaxies your destinations. Now let's return to our twins Stella and Scott. They are not just any twins, they are part of an extraordinary experiment that explores the boundaries of time and space. Scott's high-speed journey means he experiences time dilation. This phenomenon, predicted by Einstein's theory of relativity, occurs when an object moves at a significant fraction of the speed of light. Time slows down for him relative to Stella. While Stella experiences time normally on Earth, Scott's perception of time is altered due to his incredible speed. This is why Scott ages less than Stella during his journey. When he returns, he will have aged only a few years, while Stella will have aged much more. The faster Scott travels, the more pronounced the time difference. This effect becomes more significant as his speed increases, making the passage of time for him drastically different from that on Earth. If he were to approach the speed of light, time would almost seem to stand still for him. This means that a journey that seems to take years for those on Earth might feel like mere moments for Scott. This concept has huge implications for space travel. It opens up the possibility of exploring distant galaxies and star systems that are currently beyond our reach. If we could build spaceships that travel at a significant fraction of the speed of light, we could potentially travel to distant stars within a human lifetime. This would revolutionize our understanding of the universe and our place within it, at least within the lifetime of the crew on board. Such advancements would not only change the way we travel but also how we perceive time and space, making the dream of interstellar travel a reality. Section 6. Breaking down the paradox. But wait, some might ask, isn't this a paradox? From Scott's perspective, isn't Stella the one moving away at high speed? Shouldn't she be the one aging slower? This is the heart of the paradox. The resolution lies in the fact that the situation is not symmetrical. Scott's journey involves acceleration. He has to accelerate to reach high speed and then decelerate to return to Earth. Stella, on the other hand, remains in a relatively constant frame of reference. It's this acceleration that breaks the symmetry. It makes Scott's frame of reference different from Stella's. This difference is what leads to the difference in aging. Section 7. Time travel, a distant dream. The twin paradox often sparks discussions about time travel. After all, if we can slow down time, can we reverse it? Can we travel to the past or future? While time dilation is real, it doesn't allow for time travel as we typically imagine it. We can't hop into a time machine and visit the dinosaurs. Time dilation only allows us to experience time at different rates. However, the concept of time travel remains a fascinating area of theoretical physics. While it may forever be confined to the realm of science fiction, it continues to capture our imaginations. Section 8. The Future of Time, a Universe of Possibilities. The twin paradox is a testament to the mind-boggling nature of our universe. It shows us that time is not a rigid, unchanging backdrop. It's a fluid, dynamic entity that's intertwined with space and motion. As we continue to explore the cosmos and push the boundaries of science, our understanding of time will undoubtedly evolve. We may discover new and even more bizarre consequences of Einstein's theories. The universe is full of mysteries, and the more we learn, the more we realize how much more there is to know. Section 9. Beyond our current understanding. The twin paradox, while explained by our current understanding of physics, still leaves us with a sense of wonder. This thought experiment, proposed by Einstein, involves a pair of twins. One twin travels into space at near light speed while the other remains on Earth. Upon the traveling twins' return, they find that they are younger than their sibling. This scenario, though theoretically sound, challenges our perception of time and reality. It highlights the limitations of our intuition. Our everyday experiences are grounded in a world where time seems absolute and unchanging. Yet the twin paradox reveals that time is not a constant, but a variable that can stretch and compress depending on one's relative motion. It forces us to confront the fact that the universe doesn't always operate according to our everyday experiences. The vastness of space and the behavior of celestial bodies often defy our common sense. For instance, the concept of time dilation, where time slows down for objects moving at high speeds, is counterintuitive but experimentally verified. Consider this. If time is relative, what does it even mean for two events to be simultaneous? In the realm of relativity, simultaneity is not absolute. Two events that appear simultaneous to one observer may not be so to another moving at a different velocity. If two observers are moving relative to each other, they might disagree on the order of events. This relativity of simultaneity is a fundamental aspect of Einstein's theory, illustrating that our perception of time and sequence is deeply influenced by our state of motion. These are not just philosophical questions. They have practical implications in fields like GPS technology, where the synchronization of satellite clocks must account for relativistic effects to provide accurate positioning data. They have real implications for our understanding of the universe. The study of relativity has led to advancements in our comprehension of black holes, the expansion of the universe, and the behavior of light in strong gravitational fields. They drive us to question our assumptions and seek a deeper understanding of the cosmos. By challenging our preconceived notions, we open the door to new discoveries and a more profound appreciation of the universe's mysteries. Section 10. The enduring allure of the twin paradox. The twin paradox, despite being a century old, continues to fascinate and intrigue us. It's a stark reminder that the universe is far stranger and more wonderful than we could have ever imagined. It's a testament to the power of human curiosity and our relentless pursuit of knowledge. And it serves as a springboard for countless other thought experiments and scientific inquiries. The twin paradox is a journey into the heart of our understanding of the universe. It's a journey that continues to inspire and challenge us. It reminds us that the universe is full of surprises. Section 11. Our place in the cosmic ballet. So the next time you look up at the stars, remember the twin paradox. Remember that time is not a constant, it's a dance. It's a dance that plays out across the cosmos, choreographed by the laws of physics. And we are all part of this cosmic ballet moving through space and time. Our experience is shaped by the very fabric of the universe. The twin paradox is a reminder of our place in this grand cosmic scheme. It's a reminder that the universe is full of wonder and that our journey to understand it is just beginning.